next we have what's called rational. Does that show up okay? No, it's not good. Pick a different color. Okay, next we have what's called rational numbers. And the definition of rational numbers technical definition is numbers that can be written as a fraction. Okay. Now what does that mean? That's the technical definition. Okay, what it means is it's all of the integers, right? So I can write these as a fraction if I want to. I just have to put them over 1. Okay. It's all of the fractions. Can be written as a fraction. That's the technical definition. But what that means is it's all of the integers, it's all of the fraction, and it's all decimals that end or repeat. Okay? So when you talk about rational numbers, you're talking about any whole number, any integer, any natural number, any fraction, and any decimal that either ends like 0.25 and then it just ends, or repeats like 0.3 where you have that little bar over top of it. So I'm just going to put like a little side note. So like 0.25 and that ends. Or here we have like, you know, you have that bar over it, so that means it's 3's forever. But then you have decimals that never end and never repeat. That's not here. That's over here. Okay, so now you see how these all nicely fit inside each other and it's all pretty? And then you have this guy over here. This is like you know, this is like your nice family that all fits together, and this is like your weird uncle. You know, he's part of your family, but you're like, oh yeah, weird Uncle Joe, he's over there, nice Joe, whatever. Okay, these are your irrational numbers. And that's symbolized with an I. Okay, and these are all non-repeating, non-ending, I didn't make this big enough, decimals. Okay. Oh, also, I didn't think about it. I need to put that in here. Just as a side note, these are perfect roots. Also, like this, you know, like a square root of 4. Like that's perfect, right? And over here, you get things like the square root of 2. It's not a perfect root. Or pi, right? We all know pi goes on forever and ever and ever, right? There's no pattern and it never ends. So it's irrational. So any decimal that doesn't repeat and doesn't end is an irrational number. And all together, these are all part of the real numbers. So this is like the real number family. Okay. And so these guys all fit inside of each other nicely and neatly. So if you're a natural number, you're just a natural number. That's the smallest set. Except, sorry, I said that wrong. If you're a natural number, sorry, that's the smallest set. So if you're a natural number, you're also a whole number, an integer, and a rational number. Okay. If you're a rational number, you might be an integer or a whole number, but if you were like 1/2, you're only a rational number. So natural numbers are everything. They're all of these, but if you're rational, the biggest set, you may or may not be these, depending on what number you are. And if you're irrational, you're over there with weird Uncle Joe. Okay? First we simplify. Okay. Well, -4 is just a -4. It can't be simplified. So a -4 is not a natural number, right? Because it's negative. It's not a whole number. So the smallest one it is it's an integer. It's also, oh, I forgot to give you guys a symbol for rational. I'm so sorry. Rational number, the symbol is a Q with like a little line inside of it. Like that. That way you don't have to write the words. You can just write the symbol. Okay, so it's an integer, it's rational, and I didn't give you guys the symbol for real either. Sorry, real is an R with 2 lines, double R. Okay. So -4 is an integer, it's rational, and it's real. Okay. If we look at the square root of 16, first we have to simplify it. The square root of 16 is 4. It's a perfect square. It's also a natural number, a whole number, an integer, a rational, and a real. Okay. Square root of 2 is not a perfect square, and since it's not a perfect square, we can't simplify it. It's irrational and real. Is that too small?
I can't see from far.
Okay. 24 over 6, I can simplify that, right? 24 divided by 6 is 4. And we already know from here that 4 is natural, whole, integer, rational, real. 3/4 is a fraction. I can't simplify it though. It doesn't reduce to anything. So it's not an integer or whole number or natural, but it is a rational and it's real. 7 is just a number. It's natural, right? You'd count to 7. It's whole. It's an integer. It's rational. And it's real. And then pi, well, pi never ends. So it's irrational and real. Okay. Decimals that end can be written as fractions. That's the definition of a rational number, is any number that can be written as a fraction. And so in order to convert a decimal to a fraction, okay, so you count the decimal places. This is how many zeros you're going to have in the denominator. Okay, so here I have 2 decimal places, right? 2 decimal places. So what I'm going to do is always a 1. It's always 10, 100, 1,000, whatever. But I have 2 decimal places, so I'm going to have 2 zeros. And then we have to reduce. 75 and 100 will both divide by 25. Maybe that'll help. And so I get 3/4. .368, 3 decimal places. So I'm going to put 368 over 1,000 because I have 3 decimal places. Well, they're both even, so they'll divide by 2, giving me 184 over 500, which are both even, so they'll divide by 2 again. And you just keep going until you can't divide anymore. Okay. 0.5 has 1 decimal place. 1 0. And these will both divide by 5. Four decimal places, so 4 zeros. And these will both divide by 25. Any number that ends in 25 will divide by 25, or that ends in 2 zeros. Okay, when you write a repeating, oh, by the way, this line is supposed to be over that 5 also, so if you'll extend it out. If you'll write a repeating decimal as a fraction, you're going to count the number of decimal places again. Okay. And you're going to use okay, but instead of zeros, we're going to use 9s now. And there won't be a 1. And then we have to simplify or reduce. Okay, so I have a repeating 3. That's 1 repeating 3. Okay, so I'm going to put that 3 over 1 9. And then I'm going to reduce that to 1/3. 45, I have 2 repeating decimals, so I'm going to put that over 2 9s. These will both divide by 9, so I get 5 over 11. I have 621 repeating, so that's over 3 9s. These will both divide by 3. If I divide by 3, I get 207 over 333, which will again divide by 3. I get 69 over 111. And if I divide them by 9, I get 61 over 111. Okay, we're going to list, hold on one second. Now that you've seen your perfect squares, looking on your list, 4. Well, 2 squared is 4, so the square root of 4 is 2. 5 squared is 25, so the square root of 25 is 5.
So you're basically times
You're, well, you know how multiplication and division are opposite of each other? Squares, like that little exponent of a 2, and then this square root symbol, it's called a radical, are opposite of each other, so it undoes it. So this is essentially like 100 is 10 squared, and so this and this, they cancel each other out, and so you're left with 10. That makes more sense. Right, because 100, if we go back here, 100 is the same thing as 10 squared. Right? So this symbol here cancels this little 2 out.
Oh.
And so you're left with a 10. It's sort of like if you add and subtract, they cancel each other out, or if you multiply and divide, they cancel each other out. So that's what you were doing here. So here I say the square root of 625. So if I look on my list and I find 625, yeah, it's 25, exactly. And 196?
14.
Okay. Now if you have a fraction, okay, this can be split like that. So this is the same thing as the square root of 25 over top of the square root of 49. So then you take the square root of 25, which is 5, and 7. Same thing here. You don't have to split it and write it split if you don't want to. You can just take the square root of each individually and just put the answer like that. But I just wanted you to know that this is the same as this, so that's the process you're doing. You take the square root of the numerator.
So you don't have to write all that down.
Yeah, you don't have to write it all down. You just look at the 36, take the square root of it, look at the 100, take the square root of it. Okay. How do we do that? 4 squared is 16. 5 squared is 25. Right? 19. Closer to 16 or 25? It's close to 16, right? It's 3 away from 16, but it's 6 away from 25, so it's close to 16. So I'm going to say the square root of 19, and you use this like squiggly equal sign. That means it's about or approximately. So it's about 4. It's not exactly 4. It's some decimal that's going to go on and on forever and ever and ever, and without a calculator that can tell you that, there's no way for you to calculate this. Like, there's no math that you can do at this level and calculate this. So you're going to make your best guess. So 4 squared is 16, 5 squared is 25, 19 is close to 16, so I'm going to say it's close, it's about 4. Okay. 38. Well, if you look on your list, right, you've got a 36, so 6 squared is 36, and 7 squared is 49. 38 is obviously closer to 36, right? So that means the square root of 38 is going to be about 6. Now, do you have to write all of this down? No. Right? I can look at this. I can go 27 is close to 25, isn't it? So this is approximately 5. I don't have to write all of this down. 85. Look on our list. We have 81 and 100. Which is it closer to? 81. So it's going to be about 9. And 628, well, 25 is 625. So this is going to be about 25. Okay. And then just remember that this means about, or close to, or approximately. So anytime you're given an example that's not exact, you put a little squiggly equal sign. Right? If they have the same sign, so it's like a matching game, right? If they have the same sign, you add the numbers and keep the sign the same. Okay. Well, when it's two positives, you guys never have any problem with that. You've been adding two positives together since you were this big. Yeah, two positives is a positive, right? It's you already know how to do that. It's when it's two negatives, or a negative and a positive, that it gets confusing. So if I have two negatives, think about money. I owe you $3, and I borrow 6 more from you. What's that equal? If I already owed you 3, and I borrow 6 more, I now owe you 9. Right? That's how you can remember it's going to be a bigger negative. Because if I owed you money and I borrowed more money, it's not going to be suddenly positive money that I have, or right? It's still negative. I still owe you. If I have 3 positives together, I just add them. 6 plus 6 is 12, plus 3 is 15. Same thing if I have 3 negatives. I owed you 5, and I borrowed 3, which meant I owed you 8. And then I borrowed another 9. And I add the negatives together, so now I owe you $17. And we must be really good friends because you keep lending me more money when I still owe you. Right? But I think money helps because you use money all the time. So if you can put things into terms of money, it's easier to wrap your brain around it. So negatives are money that are owed. Positives are money that you have, like positives, you have money. Negative is owed money. Okay. If we have different signs, okay, so they don't match, you're going to subtract the numbers. Mm-hmm. It's okay. You're going to subtract the numbers and you're going to keep the sign. Okay, and now I'm going to use a non-technical mathematical term here. I'm going to say you keep the sign of the bigger number. And I can't say greater number because a positive number is always greater. Right? So positive 2 is greater than negative 10. But 10 is bigger than 2. So you're going to use the bigger number. Okay? So it's like this. I have a negative 6 and a positive 2. They don't match, so I'm going to subtract it. So I'm going to do 6 minus 2. Okay, so I'm going to say 6 minus 2 is 4. Okay? But negative 6. 6 is bigger than 2, so my answer is negative 4. Okay, think about it in terms of money. If I owe you $6 and I give you 2, I still owe you 4. Okay. Positive 10 and negative 4, I do 10 minus 4, which is 6. And the 10 was bigger, and it's positive, so my answer is positive. Again, you can use money. If I owe you $4 and I have $10, I can give you 4 of it, but I still have 6 left. Okay. If I have a string of 3 numbers like this, I tend to add the negatives together first. So I have a negative plus a negative. Those match. So that's negative 16. And then plus 13. Those don't match. The 16 is bigger. So I'm going to do 16 minus 13, which is 3, and because the 16 was bigger, it's negative. And then negative 15 plus 12, I subtract, and the 15 was bigger, so it's negative. It is positive. So if you have minus and negative, you replace it with a plus. These are just little tricks to remember. Okay, so 5 minus negative 9 is going to be 5 plus 9. Here, that first sign, it doesn't change, but I have minus 13, so that's plus negative 13. So if it's just a minus sign, it becomes plus negative. If it's minus a minus, it just becomes a plus. Convert it to addition, then you just follow the same rules as we had before. And the reason we do this is because it's easier to add than to subtract. So here I have a negative and a negative, so they're the same sign. So I add them and keep the sign the same. Okay, here, opposite signs. So I'm going to subtract them. 15 is bigger, so my answer is negative. Opposite signs, so I'm going to subtract, and then the 12 is bigger, so my answer is positive. Here we have same signs, 5 plus 9 is 14. And here I have same signs again, so I add them, and they're both negative. If you have the same sign, your answer is positive. Okay, so this is like a matching game. Again, if your signs match, yay, you win, it's positive, woohoo. Okay, two positive numbers times each other, you guys have no trouble with that. You've been doing that for years and years and years. So 8 times 4 is 32. Okay. Two negatives, my answer's going to be positive because I've got matching signs. Okay, same rule for division. Two positives, so 25 divided by 5 is a positive 5. Negative 36 divided by negative 12 is a positive 3. Here, I have two negatives. Negative 3 times negative 10, so it gives me positive 30 divided by positive 5, so that's positive 6. Okay. So anytime they match, positive answer. Now this is where it gets confusing between multiplication and addition. In addition, if your signs match, you add them together and keep the sign the same. So if you have two negatives, in addition, you have a negative answer. Whereas in multiplication, if you have two negatives, you have a positive answer. So just do the best you can to keep that straight. And this doesn't really work with money, right? Whereas adding works with money. If I have negative money and I borrow more money, it's more negative. But that's not the case. If I multiply negative money times negative money, I don't suddenly have positive money. If that was the case, I would take all my bills, I would just multiply them together, and I would be a millionaire, right? It would be fantastic if it worked that way, but it doesn't. Okay, if you have different signs, if your signs don't match,
Yeah, so you just multiply all of them.
yeah, and if they don't match, your answer is going to be negative. So negative 5 times positive 3, they don't match, negative 15. 11 times negative 2, negative 22. And you'll notice, like here, the bigger number's negative, here, the bigger numbers, that doesn't matter. It's just they don't match, so your answer is negative. That's negative 4. This is negative 9. Here, I have 4 times 5, that's negative 20, divided by negative 2. So what's my answer going to be now? I had the opposite signs give me a negative, but now I have a same sign, and it's going to be positive 10. Okay. Now, did I put a screen in for this? I did not. Okay. If you have, let's just make a little side note, okay? I'll put it up here. If you have a string of numbers, okay? You have a string of numbers. You know how sometimes they'll give you like a whole list of numbers to all multiply together? And some of them are positive and some of them are negative. If you count up the negatives, so like go down the list and count negatives. Okay. If your number is even, your answer is positive. If it's odd, your answer is negative. And if you think about that, every time you have matching signs, so every 2 negatives gives you positive. If you have an even number, you have a bunch of 2s. So all of your negatives will cancel each other out and become positive. Whereas if you have an odd number, you have a bunch of pairs that match up, and then you have this one extra left over that makes your whole answer negative. So this is nice because it means that you don't have to try to keep track as you're going down the list of positives and negatives. You can go look at the whole list, count your negatives, and go, okay, my answer is going to be positive. And then you can ignore it from there on. You can just multiply or divide. Same thing with if you count it all up and you go, okay, my answer is going to be negative. Then you can just do all your multiplication and division and just know that when you write it down, you make it negative. It saves you from making like mistakes along the way. So I don't know if anybody ever told you that trick before, but it's a good trick. I like tricks. Things that keep you from making mistakes. I like those. Okay. Where's my recorder? Or if you don't want to memorize the formulas, you add up all the sides. Okay. But I'm going to give you the formulas too. This is the length. This is the width. So the perimeter of the rectangle is 2 times the length plus 2 times the width. Or you can take this width, you can take this length, and you can just add them all up. Same thing for parallelogram. Squares have all the sides are the same. So the perimeter of a square, you just multiply by 4. And then with a triangle, you actually have to add up all the sides. Okay. Now the perimeter of a circle has a special name, it's the circumference. Okay. And the formula for circumference, there are 2. Okay. They're really the same thing because the diameter of a circle, that's D, right? Oh, wrong color. Diameter of a circle is twice the radius. So if the radius is halfway, the diameter is the whole thing, right? If I take this 2r, it's the same thing as that d. So the formulas are the same. So basically, you use the one that makes sense based on the information you're given. So if I give you the diameter of a circle, oops, and I say it's 12, I can either use pi d, oh, pi, by the way, is 3.14. So that's 3.14 times 12.
Pi is 3.14.
Yeah, yeah, always. So that's 37.68. Or I could take the radius, which means I'd be dividing it in half, which is 6. So I'd end up with the same answer though. So it doesn't make sense at that point to divide the diameter by 2 in order to multiply it by 2 again. So if they give you the diameter, you just multiply the diameter times pi. If you're given the radius, then you multiply it by 2 times pi. Okay. And then I need to give you your homework assignment really fast. Okay, so do you have that? So you're doing chapter 0, section 2, every other odd. I don't need to record that.